All right, as promised, here comes your review video for the circles test. All right, a lot of this stuff was taken from tests that were, I don't know, 3 and 4 years old. So that's why they look like test questions. No, there's not going to be true false on this test. We used to do that back in days when we were producing students that were softer than you guys. So we don't do that anymore. All right, but these are good concepts to know about, and these are going to be things that will help you on this test. So why not? The chord of a circle that passes through the center is called diameter. Yes, I can't see that. What's going on? Oh, I know why. Oh, that's really big. Okay. The measure of a central angle is equal to the measure of its intercepted arc. Measure of a central angle. So think about what that means. Measure of a central angle. All right, the central angle is, that kind of angle, an angle that's at the center. And that is the same thing as the arc. So yes, that's true. That's better. If a radius of a circle bisects a chord of a circle, the radius of a circle bisects a chord, so if that hits a chord perfectly in half, then the radius is perpendicular. Yes, that's one of the theorems we did. This would be the equation of a circle. The center would be positive 4, negative 3. Yes. Wow, these are mostly true. Why did I say false on the first one? Now that I say, hey, they're all true, why did I? Yeah, okay. A chord of a circle that passes through the center is called the diameter. Yes. Okay, I'm glad I caught that. All right. If two circles are concentric, like that. Whoa, that's a bad picture. If they have the same center, they can't intersect. That means that the center of one circle is on the other circle. No, it means it's the center of the other circle. AB is tangent to C at B. Something like this. If AD is tangent to circle C at D, okay, that means so it goes through A and it's tangent somewhere else, and that's point D. Then AB is congruent to AD. True. Wow, all these are true. I took some off this because there's some stuff we didn't cover this year. There must have been some false ones elsewhere on that test. Oh, here's a few more. If you haven't noticed, this is the notation for arc. When we copy pasted this from one old computer to a new computer, the font stuff didn't agree, so that looks a little funny. Anyway, not hard to figure out. Arc QR, does that equal the arc of PS? Yes, it does. It equals in terms of arc measure. Those are the same arc measure because they have the same size central angle. They are different lengths, but that's not what this question is saying. It's asking, do they have the same measure? And yes, they do. The measure of arc QR is that half of the rest of the circle except for PWS. Don't think so. PWS is this whole big one. 360 minus that would be this one. Half of that would be, no, it would not be QR. It would be like an inscribed angle across the circle or something like that, but not. This would have been equal if this half wouldn't have been here. That's the problem. Arc SU is greater than QT. SU, this one, is greater than QT. Well, it doesn't look like it. In fact, I'm pretty sure it is impossible because QT has to be bigger than RT, and so yeah, this inequality is backwards. So okay, so I said number 8 was false. Sorry about this, kids. I said number 8 was false, and then I wrote true there. So be sure to check your answers. I've made 2 mistakes, and I've caught them before going on. Okay. Make sure I got all of it. Okay. Multiple choice. If quadrilateral JKLM is inscribed in the circle and angle J and angle K are supplementary, then angle J, okay, now wait a second, I gotta draw this. Because when we call it JKLM, remember, those are in order around the quadrilateral. I'm trying to draw this randomly looking JKLM. So when they're talking about J and K being supplementary, J and K necessarily wouldn't have to be supplementary in our circle rules in general. Remember, J and L have to be supplementary. But this is saying if J and K are supplementary, so that thing plus that thing is 180. Well, then I know these are parallel. That's an old CIA rule. Then angle J, I believe it has to be congruent to. It has to be congruent to M. I mean, think about this. J and L are supplementary. J and L are supplementary. J and K are supplementary. So that means L and K will have to be congruent because they're both supplementary to J. And and K and M are supplementary, and K and J are supplementary, so M must be congruent to J because they are both supplementary to K. So J and M must be congruent. That's a cool question. Doesn't happen very often, but that's got to be an isosceles trapezoid. All right, some terms to define. This is like the beginning of your last quiz. Let's see what we got here. Inscribed angle. All right, an inscribed angle is an angle where it's on the, the vertex is on the circle, so it's got to look like that. And it's an angle we're talking about. So this is going to be angle something something, and this is like matching. So we gotta look for the one we have on here. Angle ACF. Technically, that would work. Is there a better one? COD? No. DAC. DAC also works. Both also can. DAC, I like better, but I also would say ACF. I think ACF is fine. ACF follows that same rule. Is there another one? Those are the only angles. People were putting things on their quiz that weren't even angles. When I'd asked for it, I think it was central angle on the quiz, people were putting like letter O or like an arc or something. It's like, wait a second, this is an angle. It's a central angle. Central angle is going to have to be an angle at the center, which is something at angle O. So COD, angle COD, that's an angle symbol. All right, a chord. A chord would be something like, oh, I'm going to just draw these while I'm at it. This is the angle at the center. A chord is something like this. It's a segment that's got its endpoints on the circle, so something like AC. In fact, is AC on there? Yes, AC is on there. Are there other ones up there in our list? AC, how about CF? No. AB, yes. AB would be okay. There's more than one up there. It's interesting. OC, no. No notation should be used more than once. Okay, this is wrong. I don't know why not, because there's two chords. AC is a chord and AB is a chord. There's nothing wrong with that. Must be a copy paste. Because when I copy pasted this from other tests, I chopped out some questions, and I must have made a mistake on that when I did that. Not a big deal. We still know what that means. All right, semicircle is the part of a circle that goes like 180 degrees around it. Can I highlight that? See, tell what I mean there. So semicircle would be like from B to H, or from B to H that way, which of course would take 3 letters. This always takes, people miss this on the quiz, this always takes 3 letters. And, the rainbow notation. So semicircle, 3 letters. The only ones up here, A, B, D, and B, A, D. A, B, D, yeah, that worked. B, A, D, no. B, A, D is too big. B, A, D is a major arc, so A, B, D. And I just said B, A, D would be the major arc, so let's just do that bad boy right now. Okay. Then minor arc is a 2-letter. That must be 2 letters. And this must also be 3 letters. So, and they all have the arc notation. Minor arc would be a 2-letter arc, so arc like CD, that's the one up here. CD surely is minor. Okay, good. Don't ever try to do 3 letters on a minor arc. Like, don't ever say arc CDB. Like, that's just silly. You wouldn't, if you're using 3 letters, the reader should know, oh, he must be talking about a major arc. So you wouldn't put 3 letters in, even if they're all crammed together, like HCD. Don't do that. Just say HD. Okay. This is definitely going to be more than one video. All right. Determine the radius of a circle with this equation. Remember, this is the center, and this over here represents r squared. So I know r squared equals 64. So don't write 64, write 8. 8 is the radius if that whole big blob of stuff on the left side equals 64. It means the radius has to be 8. 30, 60, 90 triangle is inscribed in the circle with radius 16. Find the length of each leg of the triangle. Okay, the radius is 16. Remember, we get 90-degree angles in triangles, and this is like a biconditional. You get a 90-degree angle in a triangle when, inscribed in a circle, when the hypotenuse is a diameter. So that's a huge piece of information. And this is 30, 60, 90. Radius is 16, so this side is 32. And 30, 60, 90, the short leg is half of the hypotenuse, so that's 16. That's equal to a radius. And this side over here is the short leg times the square root of 3. Just because it's in an old unit doesn't mean you can forget it. Find the length of each leg. Done. Simplest radical form. Done. All right. Number 1 down here. For the problems involving diagrams, do not use a protractor, of course. Penta is a regular pentagon. What's the arc P to N? Well, that's just two of these arcs that are that we see here, and each one of those is congruent. And there's 5 of them that go around the circle. I can figure out what each one of them is pretty quickly. Like each one of these little arcs here is 360 divided by 5, which I believe is 72. So there's kind of 2 of those here. So I just take 72 times 2. I get 144. You could get really fancy there and trying to figure out what these angles are inside the pentagon. I think you can just kind of look at this conceptually and go, well, there's 5 equal ones there. Obviously, each chord of this regular pentagon is congruent, and if chords are congruent, then their arcs are congruent. There's 5 of them. They make up the circle. Let's divide by 5. All right, UPR. Okay, if this is 130 and this segment's congruent to this segment, remember my piece of advice on these, which is if you get stuck, I have 2 pieces of advice on. If you get stuck, and this one is, if you get stuck, just start filling in things you know all over the diagram. Fill in arcs, fill in any angles that you know, just to because you never know what might help you, and the answer to one part of the diagram over here might be found in a completely different part. So don't focus in on the part you need because the answer might be really far away and you're going to miss it. All right, so I'm just going to start here. I call this kind of the shotgun approach. I'm gonna mark in things that I can find. So knowing that these 2 segments are congruent, because they rarely give you something you're not going to need. I'm going to need the fact that these 2 chords are congruent. They told me that for a reason, and the reason is, well, associated arcs are congruent. So this is also 130. Oh, if those are 130, I've got 2 of them there. This must be 100 to add up to 360. Okay, great. Now what else can I fill in? If this is 100, then this is the central angle associated with it, so it's also 100. This angle down here intercepts that 100, so it's 50, and by now I probably have all the information I have to answer whatever question they throw at me. I don't know what these angles are. No, I don't. I don't know what those angles are, but I'm pretty good on the rest of the circle. All right, so what are they actually asking for? Oh, UPR, that was easy. I'm a little beyond that. I actually know UTR, so good for me. The question probably on your test will have multiple parts, and it'll ask for maybe all this stuff that's in red, so just be ready. And it didn't take long to do that. It took me long to explain it, but it didn't take long to do it. Like this one, not even looking at the question yet, I'm looking over here. This is 125, that means this has to be supplementary, so this is, what, 55? If this is 55, then I know the arc associated with that over here has to be 110. If this is 125, I know the arc associated with this, or really the rest of the circle other than the 110 I just made, is 250. All right, now hit me with your best shot on these questions. All right, what's A? Oh, A is this thing down here. Oh, no problem. This is 105. This whole thing is 250. So A down here must be 145. See how painless that is when you've got all the ammunition you can possibly muster? All right. PEQ. Yeah. PEQ. This whole thing all the way around here is 275. Whoops, 275. Those are radii. Okay, well, thank you very much. Well, if that whole thing's 275, this little arc right here is the rest of the circle. So 280, 360. Is that right? That doesn't seem right. Okay, is that 360? Yeah, it's 360. PAQ. Oh yeah, if this is 85, then I know this whole angle is 85, and this angle that's the angle at O. This arc, this angle A intercepts that 85, so this is half of that, and I think that's what they're actually asking for. Yeah, that's not so bad. The other angles in that picture, I don't think I can actually find. I'm gonna stop here. I've only got 45 seconds left. I'll pick up in part 2 right where I left off here.